This is Solving Linear Systems, Substitution, Elimination, and Calculator Methods, Example 1. We have a system of linear equations where you have 5x minus y is equal to 7, and we have 3x plus 2y is equal to 12, and we want to see if there's a solution. Now when we have two lines, which are what these functions are, and we have a system of lines, there's different solutions we can possibly have. If the two lines intersect once, which they can only intersect once, then they'll have a solution of an ordered pair of where they intersect, of x and y, and the type of system it will be considered will be consistent. If the two lines are parallel, then there's no solution because they'll never intersect, and the type of system that would be considered is inconsistent. If the two lines are exactly the same, then there's infinitely many solutions because they're always intersecting with each other, and the type of system that's considered is dependent. So we're going to find out if this system of linear equations intersects at all. So we have these equations and we want to solve them using substitution. That's our method. There's different methods, but for this example we'll use substitution. So I'll color code these equations. The first one is going to be red, and the second one will be blue, and hopefully this will help you see more what's happening. So for substitution, we're going to take either one of these equations and we're going to solve them for one of their variables. It actually doesn't matter which one they are. So we could solve this equation here for y, we could also solve it for x. We could take this one and solve it for y or x. It actually does not matter. But I see the easiest one to solve for a single variable will probably be y for this first one. This y is easier to get alone. So I'm going to take this equation right here and solve for y. So I'm going to subtract this 5x from the 7. So we have negative y is equal to 7 minus 5x. And then multiply each side by a negative. So we have y is equal to 5x minus 7. I simply switch these around. So now we have y is equal to 5x minus 7 from this first equation. And what we're going to do now is we're going to substitute this y is equal to 5x minus 7 into the second equation here. So taking that, we have 3x plus 2. And we're going to use this y is equal to 5x minus 7 for this y right here. So I'll color code that, 5x minus 7 is equal to 12. So we have 3x plus 2 times 5x minus 7 is equal to 12. And you'll notice that now, instead of having two variables, x and y, we now only have one variable, x. And so we can now solve the equation, this equation, for the variable x without y getting in the way. So I'm going to switch to a new page and do that. So we have 3x plus 2 times 5x minus 7 is equal to 12. So we're going to distribute this 2. We have 3x plus 10x minus 14 is equal to 12. Just distributing that 2 and we get 10x minus 14. We can add this 3x plus 10x, that's 13x. And we're going to add 14 to both sides. So 12 plus 14 is 26. And then dividing by 13 on both sides, we get x is equal to 2. So we have solved the x part of our solution. So we know that these two lines intersect where x is equal to 2. So now we need to find what our y is. So remember, our solution is a ordered point, an ordered pair, excuse me, at a point x, y. So we need to find our y value. So now that we have x is equal to 2, we can go back and we know that these two lines both intersect at x is equal to 2. So all we need to do to find the y point is substitute x into either of these equations. It doesn't matter which one. So we could put this 2x is equal to 2 into 5x minus y equal to 7 and solve for y. Or you could put 3 times x is equal to 2 plus 2y is equal to 12 and then solve for y. It does not matter. For simplification purposes, I will simply use this where we already solved for y, because that's easier. We already solved this equation for y. So if I substitute x is equal to 2 here, it's easier. So we had y is equal to 5x minus 7 from before when we solved the first equation for y. So we're going to use this x is equal to 2. So we have y is equal to 5 times 2 minus 7. So y is equal to 10 minus 7, which is 3. So we have y is equal to 3 and x is equal to 2. So our solution then, these two lines do intersect at the point 2, 3. So it's what you would consider then to be a consistent solution, consistent system. And if we graph it, we can see we have in red here 5x minus 7 is equal to 7, 5x minus y is equal to 7, and 3x plus 2y is equal to 12. And they intersect at the point 2, 3. Lines can only intersect at one point.